Today we want to start with chemical reactions and types of chemical reaction. So let's see chemical reactions, or we call it let's say types of chemical reactions in chemistry. So we normally use equation to represent chemical reactions, and chemical equation is a shorthand method of using chemical formulae to represent the chemical or physical change This is the definition of chemical reaction. An arrow is usually drawn from the reactant to the products. This arrow means to produce. When reactants react to produce the product, so the left hand side contains the reactants, while the right hand side contains the products. This is right hand side. Then what is the definition of reactants? Reactants, definition 1. These are the substances combined together or disappearing during a chemical reaction. That's the definition. Why the products? These are the substances that are newly formed or appearing during a chemical reaction. These are the definitions of the reactants and the products. For example, let's say you have sodium, for example. Let's say we have sodium. Let's say we have sodium, for example, plus ACl, dilute hydrochloric acid, to form sodium chloride plus hydrogen gas. You can balance the equation. Hydrogen 2, you can put 2 here, equation is balanced. Chlorine 2 here, equation is balanced. Chlorine is sodium 2, you can put 2, equation is balanced. Sodium and dilute HCl are the reactants here, while the product are sodium chloride and hydrogen gas. So this is known as chemical reaction. Then we want to see types of chemical reaction. Types of chemical reaction. Types of chemical reaction. Number one, we want to see displacement reaction. We want to see displacement reaction. That's number one, displacement reaction. This is a chemical reaction where an element or a substance, usually an element, combine or replaces, let's say replaces another element, another substance or elements from its compound. That's the definition of displacement reaction. E.g., you have zinc chloride, zinc as a metal, plus ACl aqueous to form zinc chloride plus hydrogen gas. You can balance the equation. Hydrogen is 2, hydrogen will be 2, chlorine is 2, chlorine is 2, zinc is 1. The equation is balanced. This type, you can see that zinc displaces hydrogen in its compound. It's able to displace hydrogen in its compound. So this is known as a displacement reaction. And in displacement reaction, we have to be very careful. Let's see another equation that involves copper plus ACl aqueous. In this regard, I will tell you that there is no reaction here. The same displacement, but no reaction, because copper can never displace hydrogen, because copper is below hydrogen in the electrochemical series. So we have to see the element above in the electrochemical series can displace the one below, but the one below cannot displace the one above. So that's why we have the arrangement of metals according to their reactivities. So that is what we call activity series or electrochemical series. Students need to understand electrochemical series or activity series when dealing with a displacement reaction. Like in this copper plus this, there is no reaction because copper. This is because copper is below hydrogen in the electrochemical series. Another name we call it activity series. Another name for that we call it activity series. So the one above cannot displace another metal above it. It's not possible. So let's see electrochemical series or activity series. Electrochemical series or activity series. Electrochemical series and activity series. Electrochemical series and activity series. So let's see electrochemical series. What do we call chemical series? This electrochemical series is very, very important under displacement reaction. So this is the arrangement. This is the arrangement of metals and non-metal, but we are considering metals for now. This is the arrangement of metals and, okay, let me add it, and non-metals according to their reactivities. According to their activities. So let's see that of metal. For you not to forget, we have a way of memorizing it. The first one we call it, you remember, popular scientist can make a zoo in the low humid country more satisfactorily good. Popular scientists can make a zoo in the low humid country more satisfactorily good. This is the arrangement. This one means potassium. This one means potassium. It means the most reactive metal is potassium. That is K. This one means sodium. That is Na. This one means calcium. That is Ca. This one means magnesium. Magnesium. That is Mg. This one means aluminium. That is Al. This one means zinc. That is Zn. Zn. This one means In. That is iron. That is Fe. This one means Tin. That is Sn. This one means lead. That is Pb. This one means hydrogen. That is H. This one means copper. That is Cu. This one means, okay, we have said copper. We have said mercury. This will be mercury. This one's mercury. That is Hg. This one means silver. That is Ag. While finally this one means gold. That is Au. This arrangement is what we call electrochemical series. As you can see on the board, as you are moving from here up, we have increasing reactivities. We call it increasing reactivities. The most reactive is potassium, while the least reactive we have it to be gold. So the element above can easily displace the one below, but the one below cannot displace the one above. Like that equation, you can see copper is here, hydrogen is above, copper is above hydrogen, and hydrogen is above copper. So copper cannot displace hydrogen, but zinc is above hydrogen. That was why we were able to write the equation for zinc when it reacts with that. So please take note of that. So that type of reaction, we call it a displacement. We call it displacement reaction. So we are going to look at some more examples on that. We are going to look for some more examples on that. Some more examples on that. If you have sodium plus A2SO4, we also give you Na2SO4 plus hydrogen gas. This reaction is possible. It's a displacement reaction because sodium is above hydrogen. Sodium is above, it's also possible. So any metals above hydrogen can be used in displacement reaction. So this is the first type of chemical reaction we have, known as a displacement reaction. Please like, comment, and share.